Something changed in July 2026 that most Windows users noticed as a number, a download size, a progress bar, a percentage that seemed to take longer than it should have. But the number was not the story. The number was the symptom. The story, the actual explanation for why your Windows update is getting dramatically larger, why future updates are going to be even larger still, and why this trend is not going to reverse, is one of the most significant shifts in how operating system security works in the modern era. It involves artificial intelligence being used simultaneously by attackers trying to break into your system and by Microsoft trying to patch it before they get there. It involves a race between two AI systems operating at a speed and scale that human security researchers working alone could never match. And it involves a consequence that lands directly on your hard drive, your bandwidth, and your patience every single Patch Tuesday, whether you understand why or not. Today, you're going to understand why. And once you do, you will never look at a Windows Update notification the same way again. Let's start with the number that launched this conversation, because it is genuinely staggering when placed in context. Microsoft rolled out a massive July 2026 Patch Tuesday update, patching a record-breaking 570 security flaws. That is a 316% increase from the 137 vulnerabilities fixed in July 2025, and a 185% jump from the 200 flaws patched in June 2026. Read that again. 316% more security vulnerabilities fixed in 1 year. Microsoft fixed more than 4 times the number of security issues compared with July 2025, when the company addressed 137 vulnerabilities in a single monthly update on a product that has been shipping and being patched for years. The natural question, the one every informed user should be asking, is whether this means Windows suddenly became dramatically less secure, or whether Microsoft's engineering team suddenly became dramatically less competent. The answer to both is no. And the actual answer is more interesting, more consequential, and more directly relevant to your computing life than either of those explanations. Microsoft found that bad actors are using AI to find bugs in Windows and actively exploit unpatched systems. To combat this, Microsoft is using its own AI system called M- to identify bugs in Windows and patch them before attackers find their way through. As a result, you're going to see larger Patch Tuesday updates going forward. This is the core of the story, stated by Microsoft itself through a director at Microsoft 365, in a public explanation of the company's vulnerability management strategy. 2 AI systems, one finding vulnerabilities to exploit, one finding vulnerabilities to patch, both operating faster and at greater scale than the human security researchers who previously dominated both sides of this activity. And the consequence of both systems accelerating simultaneously is more patches, delivered faster, in larger packages, on a more urgent timeline than the old monthly cadence was ever designed to accommodate. Let's understand what M- actually is, because the tool at the center of this shift deserves more than a passing mention. M-, Microsoft's multi-model agentic security scanning harness, is an AI-powered security analysis system that Microsoft has built and deployed to systematically scan Windows codebase for vulnerabilities. It is not a simple automated scanner of the type that has existed in software development for decades. It is a system built on large language model technology, capable of understanding code at a semantic level, meaning it can reason about what code is intended to do, identify gaps between that intention and the actual implementation, and flag potential security implications that simpler pattern matching tools would miss entirely. Traditional vulnerability discovery in a codebase as large and complex as Windows was, historically, a combination of manual code review by human security researchers, fuzzing automated testing that feeds unexpected inputs to software to find crashes and unexpected behavior, and static analysis tools that flag known patterns of potentially dangerous code constructs. All of these methods have been used by both Microsoft's internal security teams and by external security researchers, who report vulnerabilities through Microsoft's bug bounty program. They work. They have found real vulnerabilities, but they have fundamental limitations. Human reviewers can only examine a finite amount of code. Fuzzing covers input space incompletely, and static analysis tools miss vulnerabilities that require understanding context rather than matching patterns. M- addresses these limitations by applying multi-model AI analysis, meaning multiple different AI models with different analytical approaches, examining the same code to Windows components at a scale and depth that human review alone cannot achieve. The company has been investing in AI-powered security tools to reduce the time between discovering a vulnerability and protecting customers. The result of deploying M- at scale across the Windows codebase has been a dramatic increase in the number of vulnerabilities identified per unit time vulnerabilities that existed in the code before M- existed, that human reviewers had not found, that fuzzing had not surfaced, and that would have remained latent risks until either Microsoft's researchers found them manually, or more concerningly, until an attacker using their own AI-powered analysis tools found them first. This last point is the one that gives the whole story its urgency. The same AI capabilities that Microsoft is using to find vulnerabilities in Windows are available to attackers. Security research firms, nation-state hacking groups, and criminal organizations with significant resources are applying AI-powered code analysis to Windows and other widely deployed software with the explicit goal of finding exploitable vulnerabilities before patches exist for them. A vulnerability that exists in Windows code but has not yet been discovered and patched is a 0-day, unknown to the defender, potentially known to the attacker, and exploitable with no protection available to users until the patch arrives. There's been a significant increase in security updates across the industry, warns Jeremy, who's a director at Microsoft 365. The industry-wide increase reflects the fact that MDASH and similar AI-powered security tools are being deployed across the software security ecosystem simultaneously, by defenders trying to find and patch vulnerabilities, and by attackers trying to find and exploit them, in a race where the prize is the security of hundreds of millions of systems. AI is changing vulnerability discovery, and Windows 11 updates are expected to become larger as a result. The software giant says that as AI helps security researchers find more issues across more code, customers will see a higher volume of security fixes included in future security releases. This is Microsoft's own explicit public statement about the trajectory of Windows updates. Not a prediction by outside analysts, not speculation from the security research community, but a direct acknowledgement from Microsoft that the size and frequency of security updates will increase, because AI is finding more issues faster than the old update cadence was designed to address. Now let's talk about the size dimension, because vulnerability count and update size are related but not identical, and the update size story has its own distinct and important dimensions worth understanding separately. Windows 11.22H2 updates kicked things off in 2022 with a 239.4 MB update, 4 MB update, but by 2025, its last update had ballooned to roughly 1 GB. Windows 11's version 24H2 is about when Microsoft really got serious about AI, and the update was a significant refresh. Although the updates began in 2024 with sizes around 1 GB, the latest update, as of April 30th, 2026, weighs in at a whopping 5.1 GB. Let that trajectory sink in. 239 megabytes in 2022. 5,100 megabytes, 5.1 gigabytes by April 2026. That is a 21-fold increase in update size in approximately 3.5 years. On a fast broadband connection, 5 gigabytes is a download measured in minutes. On a slower connection, it is tens of minutes to over an hour. On a metered connection with a monthly data cap, 5 gigabytes consumed by a single mandatory monthly update is a significant and potentially costly portion of an entire month's allocation. And unlike discretionary content, streaming video, game downloads, software you chose to install a mandatory security update is not something you can simply skip without accepting real security consequences. Looking at 24H2 update sizes since launch, from around 200 to 500 MB in mid-2024 to consistently 3 to 4 GB by late 2025, the upward trend is clear and doesn't look like it's reversing anytime soon. Windows 11 is accelerating that pattern. The acceleration is not expected to plateau. The factors driving update size growth, more security patches per update, expanding AI feature components, additional runtime infrastructure for on-device AI processing, and the cumulative update model that bundles everything together are all increasing rather than stabilizing. The yearly storage cost per architecture per distribution point has gone from roughly 11 GB in the 2024 cadence to 52 GB in the 2026 cadence. For enterprise IT departments managing update distribution across large device fleets, this growth is not a minor inconvenience. It is a storage and bandwidth management challenge of a different order of magnitude than what the same teams were planning for 2 years ago. What is actually inside these growing updates? The answer has several components, and understanding them separately is important because they have different implications and different levels of user control. The first and most significant component in terms of security urgency is the security patch payload, the actual fixes for the vulnerabilities that MDASH and other security analysis tools have identified. More vulnerabilities found means more patches written, tested, validated, and bundled into the cumulative update. The July 2026 security patch payload was larger than any previous Patch Tuesday, specifically because 570 vulnerabilities were being addressed simultaneously, each vulnerability requiring its own patch code, its own testing validation, and its own inclusion in the cumulative package. The second component is AI feature infrastructure, the runtime components, model files, and processing infrastructure required to run Microsoft's expanding on-device AI features. PCs with more than 32 GB of RAM can now run larger local AI models without tripping over memory allocation policies. Microsoft says the tweak was designed to unblock on-device inference workloads for high RAM configurations. Each expansion of the on-device AI capability, Copilot features, intelligent search processing, Windows Studio effects for camera and microphone, and the growing range of AI-powered features being added to Windows 11, requires shipping additional model files and runtime infrastructure through the update system. These components are not small. AI model files are, by nature, large. The quantized optimized versions shipped through Windows Update are substantially smaller than the full precision models used during training, but they are still measured in hundreds of megabytes to multiple gigabytes, depending on the specific capability being shipped. The third component is the structural issue identified in Windows' latest April 2026 investigation, the checkpoint cadence problem. After a checkpoint was established in September 2024, updates were relatively small through April 2025. Then, the May 2025 update nearly tripled in size, jumping to over 4G glotter in the catalog. A year later, there still hasn't been a new checkpoint, which means the size savings Microsoft promised are quietly eroding. Windows uses a cumulative update model where each monthly update contains not just the current month's changes, but all changes since the last checkpoint, a baseline snapshot against which differential updates are calculated. When a new checkpoint is established, the differential size resets to small, and updates are compact again until the accumulated changes grow large enough that the next checkpoint is needed. Microsoft has been slow to establish new checkpoints relative to the pace of changes being added, which means the cumulative payload continues growing even beyond what the raw volume of changes would strictly require if checkpointing were managed more aggressively. What makes this unusual is that the compressed MSU file grew by roughly 3 GB, while the decompressed file grew by only 5 GB. Looking more closely at the May 2025 cumulative update, dozens of MSIX files were not present in April, including PS Tokenizer, Text Recognition Session, PSonics Runtime Query Processor. These additional MSIX files, packaged application components for AI-related features, represent the AI infrastructure being shipped through the update system, and their sudden appearance in large quantities in the May 2025 update was what caused the most dramatic single-month jump in update size. Similar additions of AI infrastructure components have continued in subsequent updates, contributing to the sustained large size of monthly packages through 2025 and into 2026. Now let's talk about the two actively exploited 0 days in the July 2026 update, because they are the most urgent and most concrete illustration of why the size and urgency of these updates matter in a way that directly affects the security of your machine. A 0-day vulnerability is a security flaw that is being actively exploited by attackers in the wild, meaning real attacks against real systems are happening, using this vulnerability right now, before most users have installed the patch that fixes it. The July 2026 update addresses 570 vulnerabilities, including 2 actively exploited 0 days. The presence of actively exploited 0 days in a Patch Tuesday release is the clearest possible signal that installing the update promptly is not optional. It is a direct response to ongoing attacks. The specific nature of these 0 days, the exact vulnerability types, the attack vectors, and the categories of systems most at risk was disclosed in Microsoft's Security Response Center advisories accompanying the July update. Without reproducing the full technical details, the general character of actively exploited 0 days in recent Windows Patch Tuesday cycles has involved a consistent set of vulnerability categories, privilege escalation flaws that allow an attacker who has already gained some access to a system to elevate their permissions to administrator or system level, remote code execution vulnerabilities that allow an attacker to run arbitrary code on a target system by sending crafted input through a network accessible service, and security feature bypass vulnerabilities that allow attackers to circumvent protections like Windows Defender or user account control. Any of these categories, if actively exploited against an unpatched system, represents a direct path to full compromise of the machine and all data on it. The 316% increase in vulnerabilities patched this July compared to last July should not be interpreted as Windows becoming 316% more dangerous. The correct interpretation is almost precisely the opposite. MDash and related AI-powered security tools identified and patched these vulnerabilities proactively, before attackers could find and exploit all of them. Most of the 570 fixes in July's update address vulnerabilities that, as far as Microsoft knows, had not yet been discovered by attackers. The 2 0 days are the exceptions, the ones where the race was lost, where the attacker found the flaw before the patch existed. The other 568 patches represent races that the defender won, vulnerabilities that now have patches before they were ever weaponized. This framing matters because it directly addresses the instinctive concern that larger updates signal a more broken product. Microsoft says the growing number of fixes should not be interpreted as the operating system becoming less secure. Instead, the company says AI is helping identify vulnerabilities earlier and at a larger scale. A vulnerability that is found and patched before an attacker discovers it is not a security incident, it is a security success. The measure of Windows security is not the number of vulnerabilities that ever existed in the code, but the number that are exploited against users, and the goal of deploying M- at scale is specifically to keep that second number as close to zero as possible by patching vulnerabilities proactively. But, and this is crucial, but that goal is only achieved if users install the patches. A patch that exists but is not installed provides no protection to the machine it was designed to protect. This is the practical tension at the heart of the update size story. Larger updates create more friction, more download time, more bandwidth consumption, more disruption to active work sessions during installation, more risk of update-related issues like the Dell thermal runaway bug we discussed in the previous episode. Each additional source of friction is a reason some percentage of users delay or skip updates. And delayed or skipped updates mean machines that remain exposed to the vulnerabilities those updates address, including the actively exploited 0 days. Microsoft is aware of this tension and has been working on multiple fronts to reduce the friction associated with large updates without reducing the security coverage they provide. Microsoft is taking efforts to reduce the download time for Windows updates, but we are not sure if it's through size reduction. Delivery optimization. The peer-to-peer update distribution system we discussed in the context of bandwidth consumption earlier in this series is one mechanism for reducing the time individual machines spend downloading updates by allowing downloads from local network peers rather than requiring every machine to download the full package from Microsoft servers independently. Checkpoint cadence management, if Microsoft addresses the drift identified in Windows' latest investigation, would help reduce the cumulative payload size between checkpoints. And the new calendar-based update pause feature identified in the July 20th Insider Preview builds a calendar-based update pause that blocks installations for up to 35 days, gives users more deliberate control over when updates install, rather than having them arrive at whatever moment Microsoft's scheduler determines. Let's talk about what the Insider Preview builds reveal about where Windows Update architecture is heading in the near term, because the features being tested in the preview channels today are the features that will arrive in stable releases in the coming months. Microsoft released 5 new Windows 11 Insider Preview builds on July 20th, spanning beta, experimental, and release preview channels across the 25H2 and 26A1 platforms. Among the changes in these builds, 2 are directly relevant to the update experience. The calendar-based pause control represents a meaningful improvement in user agency over update timing, rather than the existing pause functionality that allows pausing for a fixed number of days from a menu. A calendar-based interface would allow users to specify specific dates around which they want to avoid update installations, accommodating known periods of heavy use like project deadlines, presentations, or events, without requiring manual update management on the specific days involved. The 32GB AI model capability PCs with more than 32GB of RAM can now run larger local AI models without tripping over memory allocation policies is relevant to the update size story because it signals that on-device AI inference workloads on high RAM machines are about to expand in scope. Larger local AI models require larger model files. Larger model files shipped through the update system mean larger updates. The expansion of on-device AI capabilities and the expansion of update sizes are directly linked. And the July 20th preview builds confirm that on-device AI capability expansion is accelerating rather than plateauing. The July 2026 security update is an early example of a major shift Microsoft has already warned about. Early example. Microsoft's own language makes explicit that July 2026 is not the peak. It is a data point on an ascending curve. The combination of AI-accelerated vulnerability discovery through M-, AI-accelerated attack capability development by threat actors, expanding on-device AI feature infrastructure being delivered through updates, and the cumulative update model's checkpoint cadence challenges all point in the same direction. Updates will continue to grow. The question is not whether, but by how much and how fast. So what does this mean practically for you as a Windows 11 user navigating this new reality? The first practical implication is that update scheduling matters more than it used to. A 5 GB monthly update on a slow or capped connection is a meaningful planning consideration, not a background event you can ignore. Reviewing your Windows Update settings, configuring active hours correctly to ensure updates install during periods when you're not using the machine for critical work, and understanding the new calendar-based pause features when they arrive in stable releases are all worthwhile investments of a few minutes given the scale of what monthly updates now represent. The second practical implication is that the security urgency of updates has increased proportionally with their size. Delaying installation on unaffected devices could increase security risks. The months when Patch Tuesday addressed a handful of moderate vulnerabilities were months when delaying an update for a week carried modest risk. The months when Patch Tuesday addresses 570 vulnerabilities, including 2 actively exploited 0 days, are months when the risk of delay is substantially higher. The larger the update, the more important it is to install it promptly on hardware where it does not cause problems, because the larger the update, the more security gaps it is closing that exist right now on your unpatched machine. The third practical implication is about storage management. At 5.1 gigabytes per monthly update, plus the Windows Update staging files that are downloaded and extracted before installation and not always fully cleaned up afterward, the storage footprint of the update process itself has become significant. Running disk cleanup after major updates, specifically using the option to clean up Windows Update files, and ensuring that your system drive has adequate free space before update installation to accommodate the staging process, are practical steps that prevent update-related storage issues and ensure the installation process has the space it needs to complete correctly. The fourth practical implication is about bandwidth and connection awareness. Delivery optimization, despite the privacy concerns about its internet-based peer sharing we discussed earlier, does provide genuine download efficiency benefits for home networks with multiple Windows devices and for corporate networks where the local network sharing option reduces the number of times the full update package needs to be downloaded from Microsoft's servers. For users on metered connections, configuring Windows Update to be aware of the metered connection status, which causes Windows to defer large downloads until a non-metered connection is available, prevents a single monthly update from consuming a significant portion of a monthly data allowance without deliberate user authorization. The fifth practical implication is about the broader competitive and security landscape that M-Dash's deployment represents. Microsoft is not the only company deploying AI-powered security analysis at scale. Google's Project Zero, Apple's security engineering team, and the major enterprise security software vendors are all working on similar capabilities for their own codebases and products. The acceleration of vulnerability discovery and patching that M-Dash is driving for Windows is part of an industry-wide shift that will manifest as more frequent, more comprehensive, and more urgently necessary security updates across the entire ecosystem of software that runs on modern devices. Windows is the most visible and most widely used example, but the pattern will replicate across operating systems, browsers, productivity applications, and the firmware that underpins all of it. The race between AI-powered vulnerability discovery and AI-powered attack development is the defining dynamic of operating system security in the current era. Microsoft has made the strategic decision to compete in that race aggressively, deploying M-Dash, expanding the scope and frequency of security patches, and being transparent with users about the trajectory of what this means for update sizes and frequency. The alternative, patching more slowly in smaller packages on a more predictable and less disruptive schedule, is not actually a safer choice. It is simply a choice to lose the race more gracefully, while the vulnerabilities that AI-powered attackers have found and that M-Dash would have patched remain exploitable on every unpatched machine. Your next Windows update is going to be large. The one after that may be larger still. And the reason is not Microsoft's engineering team losing control of the codebase or AI features bloating the operating system unnecessarily. The reason is that an AI system is working around the clock to find every exploitable flaw in the software you run before an attacker's AI system finds it first. And every vulnerability it finds requires a patch, and every patch makes the update larger. And every large update that installs on your machine closes a door that might otherwise have been left open. The size is the price of the protection. Now you know exactly what you're paying for.